All right, let's get right into it. Today, we're tackling one of the biggest stories of our time, how AI, artificial intelligence, finally learned to see and hear. And trust me, this isn't science fiction anymore. This is the science that is literally powering the world all around us.
So, you gotta ask, right? What was the big change? How did we go from clunky robots in movies to cars that can actually drive themselves and phones that get what we're saying? For the longest time, this stuff was just a dream. But then something fundamental shifted. A perception revolution that took computers from being basically blind and deaf to having senses that are, in some cases, even better than ours. And we're gonna break down exactly how that happened.
So, first things first, we have to understand the wall that AI researchers were banging their heads against for decades. It all came down to a single, massive issue, the perception problem. I mean, how do you even begin to teach a machine to recognize something as simple as a cat in a photo?
You see, the old way of doing AI was all about writing rules. Hard-coded, rigid rules. You'd tell the computer, okay, if you see a bunch of pixels that form a round shape and it's above two little triangle shapes, well, that might be a cat. But the real world is it's messy. The lighting changes, the angle is different, and cats, well, they come in all sorts of shapes and sizes. These rule-based systems were just way too brittle. They broke constantly.
So what changed? What was the breakthrough? Well, the answer came from a totally new approach, one that was inspired by the most powerful perception machine on the planet, our own brain. And this was the start of the deep learning revolution.
Okay, so let's meet the first hero of our story, the Convolutional Neural Network, or CNN for short. Now, the amazing part about this is that it's directly inspired by biology. Scientists literally modeled CNNs after how our own visual cortex works. Instead of using a bunch of rigid rules, it learns to see by processing an image in layers, starting simple and getting more and more complex.
Here's a good way to think about it. Imagine a CNN is like a series of digital microscopes. The very first layer might only see really basic stuff, like simple edges or blobs of color. Then the next layer takes those edges and blobs and combines them into simple shapes, like circles or squares. The layer after that might combine those shapes into things that look like eyes or a nose or a mouth, until finally, the very last layer puts it all together and goes, aha, that's a face. It's this beautiful hierarchy of understanding.
But okay, that's vision. What about things that happen over time, like, say, a sentence you're speaking or a piece of music? For that, we need our second hero, the recurrent neural network, or RNN. If CNNs are the masters of space, then RNNs are the masters of sequence, of time, and their secret sauce is a kind of memory. It allows them to understand context because they can remember what came just a moment before.
So let's put it all together, because this is the key takeaway. They're really two sides of the same perception coin. CNNs look at a whole picture all at once, understanding how all the pieces fit together in space. RNNs, on the other hand, process a sentence one word at a time, understanding how the order of those words creates meaning. It's like one sees the world and the other hears it.
And if you had to point to one single moment that lit the fuse for this whole revolution, it was this one. Back in 2012, a CNN called AlexNet just completely destroyed the competition at this huge image recognition contest. And I mean, it didn't just win. It cut the error rate almost in half compared to the next best thing. That sent a shockwave through the entire AI community. It was the signal that a brand new era had officially begun.
Okay, so this isn't just some abstract theory in a lab. Let's look at how this revolution exploded into the tech we all use, literally every single day. Because once the fire was lit, things started moving incredibly fast.
You see a self-driving car navigating a busy street? Its eyes are a bunch of CNNs, all working together to identify pedestrians, traffic lights, and lane markings, all in a fraction of a second.
Or think about hospitals. CNNs are now being used to analyze medical scans, spotting the early signs of diseases, sometimes with an accuracy that can match or even beat a human expert. It's incredible.
And yeah, every single time you talk to your phone or your smart speaker, you are interacting with an RNN. That's the magic in the background, taking the sequence of sounds you just made and figuring out the command you're giving it.
But it even goes beyond just seeing and hearing. Remember the famous AlphaGo system? It used deep learning to master the unbelievably complex game of Go. And it wasn't just seeing the board, it was simulating future strategies, a feat that started to feel a lot less like pattern recognition and a lot more like actual reasoning.
So, this power is obviously transformative. I mean, it's changing everything. But, and this is a big but, it also forces us to grapple with some really difficult new realities. and to ask some very, very hard questions.
Because for all of this amazing stuff, the accuracy, the ability to automate things, all these incredible new tools, there's another side to the story. These models are incredibly data hungry, meaning they need massive, massive data sets to learn. They take a ton of computer power and energy to train. And there's a real risk that if we're not careful, they can actually end up repeating the worst biases found in our own data.
And that leads to these really sticky ethical dilemmas. I mean, think about this one for a second. If an AI system makes a mistake, a serious mistake, who's on the hook for that? Is it the programmer who wrote the code? The hospital that decided to use it? The company that sold it? Our laws and our ethics are still playing catch-up.
A huge part of the problem is what people in the field call the black box issue. We don't always know how these systems get to an answer. We can see the photo we put in, and we can see the label that comes out, but the complex reasoning that happens in the middle, it's often a total mystery. And it is really hard to put your full trust in a decision that you can't understand.
So where are we headed from here? Well, the revolution that kicked off with CNNs and RNNs, it's not slowing down. In fact, it's already evolving into its next, even more powerful phase.
We're seeing brand new types of models, like transformers, that are just taking over everything. There's this huge push towards what's called multimodal AI, systems that don't just see or hear, but can do both at the same time and connect words to images. And thankfully, there's a ton of research going into explainable AI, trying to crack open that black box so we can actually understand the why behind the AI's decisions. Ultimately, the whole ambition of the field is shifting. The goal isn't just to perceive anymore, it's to comprehend. The new goal is to build systems that can actually understand context, that can reason about the world, and that can interact with it in a way that feels much more fundamentally human.
And as we push closer and closer to that goal, we're doing more than just building better gadgets. We are actively, right now, blurring the boundary between artificial and biological intelligence. And that's forcing every one of us to ask what it really, truly means to see, to hear, and to understand. Thanks for tuning in.